they encouraged me to tell you just a wee bit about who I was because I'm sort of the odd man out in this room. I am a technologist. I've been playing with computers for over 40 years, I'm afraid, and on the internet since there were just over 100 machines on it. My mentor used to tell people his address was Steph at any machine on the net. That's not going to happen again. And what I'm best known for is the MIME standard, which is what lets you put pictures and sounds and basically anything other than ASCII English text into email and web pages and stuff like that. Books, startups, patents, that sort of thing. Oh, and that was my barbershop quartet in 1991 when the MIME standard was being devised. The first MIME message sent out around the world was us singing "Let Me Send You Email" in 4-part barbershop harmony, and if you go to my webpage, you can hear me miss the high note. So I'm going to try to just give you a little bit of a level set and background for the rest of what's going on today, both what the cloud is and a little bit of historical perspective. The cloud is really a very simple concept. It's gotten way too complicated by people who need to talk for a living. It's been complicated with jargon. I'm going to give you a little bit of jargon as we go on that strikes me as the only essential jargon. I hope I'm right. But first I want to tell you what the cloud is in 7 words. Outsource computing to focus on your business. Really, really simple concept. And not in any sense a new one. In fact, it was sort of the idea starting about 10 years after the first business computer when businessmen were getting thoroughly sick of everything they had to do to run their computers. So it's a very old idea, and we're going to talk a little bit about why it's taken this long to come true and whether it's really coming true. But as I said, a little bit of the jargon does matter, so we'll talk about that too. So first of all of this has happened before and will happen again. We're in a series of repeating cycles in history. Some of you may have been Battlestar Galactica fans. That's a line from Battlestar Galactica. What I want to talk about by way of analogy is actually a building in Waltham, Massachusetts, where Mimecast has its US headquarters. This building, which you can see here, is known as the Watch Factory. And it's been renovated and it's full of high-tech offices like ours. But it's known as the Watch Factory for a very subtle reason, which is that it used to be a watch factory. And goes back to almost the beginning of the 19th century. Now, back then, it made a whole lot of sense to build something like a watch factory on a river because you could get power. You could put in your own water wheels and then later dynamos. And if you had that and your competitors who made watches didn't, you had a competitive advantage. You had access to power. But the price that you paid for that was you had to employ people who kept the water wheels and the dynamos working and who were experts in electric generation and stuff like that. That made sense in 1840 or 1850. I may have the years wrong. But there came a day when it was just obviously more sensible to chuck all of that and start using power from the power company. That is pretty much what we're going through with most computing functions today. There was a time 20 years ago when a business that picked up email got a competitive advantage, and it justified having a bunch of people in-house administering a bunch of ever more complicated email systems. Nowadays, it's not a competitive advantage, it's a necessity, but there's so many people using it that there's a lot of experts out there, and there are companies like Mimecast, but there are plenty of others, that can do it on a massive scale that very few other companies are likely to be able to match. And so therefore at a much better price point. So this is just like what's happened with other technologies before. And it is, as I said, a dream as old as computing, and those of you who've been around a while have probably heard similar claims made for time sharing, for client-server architecture, for hosted infrastructure, for application service providers. And basically, the specialists would tell you this is going to take most of your problems all away from you, and then the instant you tried it, you ended up like Charlie Brown. The football was yanked away. How'd that happen? You were disappointed, and the question is, how do you know Lucy's not going to pull the football away again? Well, before I answer that, why have we wanted this for so long, and why has the desire persisted through all these disappointments? First of all, there's concentration and sharing of expertise. The things that go on to run complex computer systems are complex, and the cost of having people who know how to do them is very high, and a business, especially a smallish business or medium-sized business, has a natural imperative to try and have as few such experts as possible, so they tend to overload them. So you don't have where you might have a really smoothly running mail system if you had 3 administrators devoted to mail. Instead, you might have 2 administrators who do mail and 7 other things. And the more you overload them, the more your bottom line looks like you're doing something smart, and the less well your system's going to function. And at some point, you're like the watch factory. It just makes sense to outsource. The other thing is, the more of your employees that are focused on the mission of your business, the better. No matter how well-intentioned, the guy in the operations center, when he hears the CEO exhorting you to think about the bottom line and make sales and stuff like that, he has no idea how to do it. His job is to keep systems running. I mean, it's a meaningless message to him, and if it's harped on too much, it can mess up morale and make him cynical. So you really don't want a lot of employees who have to focus on something other than your mission. Another one that's remarkably simple is improve the quality of service. It's very hard for you to have a couple of administrators running anything as well as a company that has scaled out to thousands of times more users doing the same service. At Mimecast, we have dozens of world-class email experts, and you pay less for a fraction of one of them than you would for 2 overburdened people doing mail and several other things. So you get better service, fewer outages, more reliable archives, all that sort of thing. And decreased cost of service. This is why a lot of people move to the cloud in the first place. It's true. I think it's far from the best reason. So these are the reasons people keep talking about stuff like this. Up to now, it hasn't lived up to the promise, but in the last couple of years, it has. So what makes this time different? Well, first of all, broadband's finally here, nearly ubiquitous. And I speak as someone who lives in a place that doesn't have good broadband, but I know how exceptional I am in that regard now. Lots of cheap, powerful devices that can take advantage of it. The onset of really sophisticated mobile devices like iPhones and Android phones they're not just cheap, powerful devices in the sense that you have more and more desktop computers. They have caused your employees to work from more and more places and created more and more complex situations that your administrators have to worry about. And if that's not clear to you, ask your most trusted administrator how he feels about BlackBerries and iPhones accessing the corporate network. And then, of course, economies of scale. In 1965, when the promise of time sharing didn't quite live up to these goals, there were thousands of computers in the world. Right? Now there's probably thousands of computers on this block. It's different. And finally, the proof is in the pudding. There's evidence now of widespread adoption. This is a pretty small graph, and I'm not going to go into the methodology. It's showing adoption rates. The methodology doesn't matter at all, I would contend, because what it's comparing is adoption in 2009 and 2010. And you can tell from the 2 colors, whatever the metric was being used, however they decided, whether it's this 33% should really be 10%, it's doubled. And all of these just about have doubled or more. So in the last year or so, this is what's happened to adoption of cloud computing. If you move to cloud computing today, you will not be an early adopter. It's too late. Okay, finally the promised jargon. And there's only 2 pages of it, I promise. When people talk about cloud services, they tend to talk about 3 delivery infrastructures. And you only need to understand this to the point of knowing which one you want, really. That's what you need to know. The one you hear about the most is software as a service, or SaaS. And this is basically having consumable services, the kind of things your business thinks about as information services, email, stuff like that, completely outsourced to the cloud. And so this includes things like Salesforce.com or Google Apps. Platform as a service, or PaaS, is a level down from that. It takes the middleware that underlies such services and makes it available as a service. And interestingly, although there are some standalone examples of this, the 2 I gave for SaaS have layers that they make available as PaaS. Salesforce.com has something called Force.com, which is available to companies that want to build applications on top of their infrastructure. And Google Apps has something called App Engine for companies that want to build new apps in the Google Apps world and deploy them in the same way. So if you're just consuming services, you're interested in SaaS. If you're in the business of building services to be consumed that way, you're probably interested in PaaS. And then a level down is infrastructure as a service, which is unfortunately often pronounced IaaS. And I apologize. And this is basically going one level down and making virtual machines available as infrastructure. So if you want to sort of say, I want some machines to access to sometimes put Windows on and sometimes put Linux on and shuffle them around and run these things on them. Basically, if you're down at that level near the metal normally, you can get one level away from it here, and you can stop running your own data centers and stuff like that. So I would guess that most people in this room care about SAS, which is good because it's easier to pronounce. And for those of you who've looked at some of these layers, this is a graphic by Kate Craig Wood, here in the UK, a really excellent blogger, in which she's tried to represent the various layers of information services and how they relate to SAS, PaaS, and IaaS. So you can see here they go back from the data center level through the networking level, physical services, virtualization layer, operating systems, and infrastructure pieces. And up to here is what they call IaaS. You add on operating systems and some middleware infrastructure, and you've got PaaS. And then you start adding things like, say, email, Mimecast, and you've got SAS. So that picture sort of hopefully graphically represents the difference between the three. That's half the jargon: IaaS, SAS, and PaaS. The second piece of jargon that you probably need to know about, because somebody will ask you to make a decision someday, is whether you want a public cloud or a private cloud. And if you're really unlucky, they'll ask you if you want a hybrid cloud or a community cloud. These are really pretty simple. A public cloud is the most obvious thing. It's a set of services that are open to everyone on the net, like Google Apps, Gmail, that sort of thing. And you are sort of sharing infrastructure with the world. That doesn't mean it's insecure. It means that you are being treated the same as a whole bunch of other people, and that there are imaginable security breaches in which some of those other people might have more access than you'd like to think about, although it shouldn't happen. But that's why people call it public, is everybody has access to the same infrastructure. A private cloud is where you own and run your own services but deploy them by the cloud. And there's a lot of argument nowadays increasingly over whether it makes sense for anyone, but if it does, it makes sense for larger corporations that are currently, perhaps having 20 locations globally with 3 administrators in each or something like that. By centralizing their services, instead of 60 administrators, they might get down to 20 running everything as a cloud-like service and still feel like they have complete control. Increasingly, people are doubting whether that's worth doing, but that's what it means. And then a hybrid cloud is a mixture of public and private, where you do some of your services one way and some the other way. And that could actually also include doing some of them as a community, so I should probably have put that third. Community cloud is probably the oddest one. This is where you have a cloud that is not a private cloud, but it's private to a small number of players. So it's sort of like a semi-public cloud, if you will. And the reason you might find that desirable, as far as I can tell, the best reason is that you're in a regulated environment. So if, for example, you're in healthcare in the United States, you have these horrendous HIPAA guidelines that you have to comply with, it may arguably be easier to do so if your cloud services take place entirely within a HIPAA-compliant infrastructure that only admits other healthcare providers. That's an untested hypothesis as far as I'm concerned. So what are the risks? The risks are, the first risk is the risk in the public cloud and everywhere else, which is that you're only as safe as your provider. And this scares a lot of people. It's one of the things that's slowed cloud adoption for many companies. You feel that you have control over that geek in the machine room, right? And that company that's selling you cloud services, you have less control, and you can't really tell what they're doing. And it's a valid concern, but it should be weighed against the fact that they probably do know what they're doing better than the geek in the machine room. So you don't have as much control over telling them exactly what to do, perhaps, but they're really experts. So the question becomes, how do you control that risk, regulate that risk? The main things that you have to do there are due diligence, which the lawyers in the room should certainly know something about. You want to make sure that you've got a provider that is reputable and that follows all the regulations that are important to you. And I put it that way because with 200 countries in the world and so on, it's probably unlikely that any cloud provider follows them all, frankly. They don't operate in every venue and so on. So what you're then going to want to do, if you think about it, is you're going to say, oh, well, I want to audit my cloud